Well, you are required to work together as squares, blah, blah, blah.
Number 3, I got, well, P, but the last one with nothing over it. Just a regular old P. And then the next one, to get a confidence interval, you need so you have that one, but you don't have like what they want for the z-score. That's the only thing you're really missing. Like what you want, you want your confidence interval to be like 95% or...
Yeah, so you have everything you need.
How so?
The requirements for constructing a confidence interval are satisfied. So we have the population.
Right.
And we have the true
point estimate of P.
Yeah.
But what about like Z? We don't know if it's like 1.96 or if they want it to be like 99% or 90% or what.
Yeah, but if we wanted to calculate that, we could, right? Like if we said we wanted to calculate a 95% confidence interval, then we would just back into the answer. Like we would solve for Z instead of solving for the confidence interval.
I see. So, I see. So wait. We'd solve for Z instead of the confidence interval. Okay. I'm a little confused. What the heck? I'm trying to figure out, like, because whenever I do the confidence intervals, it's never like, okay, so you just to throw an integer out there, like x equals, p minus the z-score, and then you have the square root of, that whole equation, p times 1 minus p divided by n.
Yeah.
And so if, just say I were to substitute, the confidence interval, say the lower bound for x, so it's x equals p minus z, whatever, wouldn't you then have just two variables then? X and the z-score?
Well, X is what, the point estimate?
No. I'm not talking about. I know X is the mean. Yeah. Normally, but I'm just like out there. Okay, I'll change it to Y. So it would be Y equals P minus Z square root, P minus or times 1 minus P divided by N. Where Y is the lower bound and Z is the z-score, right? So then wouldn't you have two variables though? So you'd have Y that you have to solve for and Z. Does that make sense?
Yeah, I see what you're saying. What's your take on this, David?
Okay, guys, I got the answers up right here. So I'm reviewing them as you guys are going through them. So you're talking about question 4.
I just want to know why. Yeah. Question 4. So it says the requirements for constructing confidence interval are satisfied. And I said, well, we don't know the z-score. And, I suppose you could try to solve to get the z-score instead. But let's input then, hypothetically, say the lower bound is equal to y, right? So your equation would look like y equals p minus z multiplied by the square root of yada, yada, yada. Well, then you'd have two variables there. So how do you solve for the z-score when you have two variables you need to solve for?
Well, are we solving for two variables or are we just solving for x?
You're not solving for either. We're trying to get, what it's asking is if can you construct a confidence interval, yes or no, from the information given above? And yeah, I don't know. I don't know how you do that. That's what I'm asking. I'm sure you can. I just don't know how.
Okay, hang on. Let me check this out. Let me look. I know it's true.
Is that what you put in your answer?
Yeah. Mm-hmm.
Okay.
Yeah, but I knew it was true because I thought I was just solving for x. I did like I did algebra with it.
Right.
So when you say you had two variables, which two variables are you talking about?
The z-score, right? So you have z, because we don't know the confidence interval if they want, 99%, 95%, or 90%. So if it's 95%, hypothetically z would be 1.96, right? But we don't know because if you're trying to get the lower point estimate, then you'd have to have say the lower point estimate is represented by the variable y. So you'd have two variables there that you're trying to solve for that you don't know, whether it's y or whether, you can't solve for two variables from one equation. See what I'm saying?
I do. I'm confused by it.
Here, let me just do this. I'll show you what I mean.
Share the screen.
Yeah, give me a sec. Y equals P minus C. So, divided by n. There. Okay, let me share. Let me share. Okay, so this is the equation, right? Or at least the one that I came up with here. So you have y, which is we're solving for the lower bound since it's minus p minus z. If it were the upper bound, then it would be this, right? So we know p, and p is 0.1, right? So we got all that. We have n. N is 100. But we don't have the z-score, and we don't know what the lower bound equals. Do you see what I'm saying?
Mm-hmm.
So I guess to simplify, the z is getting the square root of 0.1 times 1 minus 1 divided by 100. Yeah. So basically what we have then is y equals 0.1 plus 0.03 z. That makes sense? So I can get, to this point here. So we have, if we're solving for the upper bound, it would be this here. As simple as I can get it. No? Do you guys understand what I'm talking about?
I don't.
Like I'm talking to a brick wall. Come on, guys.
One z-test. Okay,
so do me a favor then. Get me the lower interval, the lower bound.
Okay. 1 sec.
That'll solve it. If you can get the lower bound, then that'll solve it.
Okay, let's see.
Hey, Mikhail, we're having trouble with this one question because he said we were trying to solve for two variables, but I don't think we're trying to solve for two variables.
I don't think so either. I think
but-
you're just going for x.
Okay, so like the lower bound, you don't know what the confidence interval is if they want 99%, 95%, or 90%. So you don't know two things. The two things you don't know are, number one, what the lower or upper bound equals.
That's true.
And number two, you don't know what they want the confidence interval to be. So those are two variables that you have to solve for that you don't know the answers to.
He just wants to know how we get it.
Okay. So the requirements. So you need to have a simple random sample and n times p hat. So n times p hat needs to be greater or equal to 10.
Oh.
And so it's like you have to check. So
So it's just a calculation where you just take p hat and times it by the sample mean, the sample size of 100. So if it's greater than 10, greater than or equal to 10, then it satisfies the requirement.
If what is n equals 100?
Yeah, so n equals 100. So 100 times 0.1 is greater than or equal to 10, right?
So if n is greater than or equal to 10,
no, if n times p hat is greater than or equal to 10, then it satisfies the requirements. And then, so that's the first one that you have to check. And then you also have to do n times 1 minus p hat to see if that's greater than or equal to 10.
So both has to be greater than or equal to 10?
Yeah, you have to do 2 tests.
okay, so you have
Does that
n
make sense?
times p hat has to be greater than or equal to 10.
Yeah.
And then lastly, it's n or n minus p hat. Is that what you said?
It's n times 1 minus p hat. So it's like n bracket 1 minus p hat.
Yeah.
What the heck? How come I didn't see any of those equations in lesson 17? Where are they at?
Videos to watch?
Huh?
You guys have like videos to watch?
I don't know. Oh, here it is. In step 4, I guess, the empirical research. N times p is greater than or equal to 10, and then n 1 minus p is greater than or equal to 10. And just from that will satisfy.
Well, it also needs to be a simple random sample.
Okay.
And then, yeah.
But to actually get the confidence interval, like, that's not another way of calculating the confidence interval, is it?
No.
What the heck? Because that's what the question is asking for, though. I know.
No, the question, wait. The question is saying the conditions for conducting a hypothesis test are satisfied, isn't it?
No, not that question. The one up above.
Oh, where? Which number is it?
Number 4, the requirements for constructing a confidence interval are satisfied. So, like, my whole thing is, well, we don't know what confidence interval they want. Like, we don't know if they want a 99% or a 95% or a 90% confidence interval. So how are we supposed to get the z-score? Do you see what I mean? Like, I know we have the p hat. I know we have n, which is the majority of the equation, but we don't have the z-score. And if you don't have the z-score, then at the very least, you'd need to know what the lower or the upper bound is, and you don't know.
In my notes, it doesn't say anywhere that you need to have a requirement for the confidence interval.
Oh, no, I'm not saying. I'm like, it's wanting to know if you can actually get a confidence interval from that information. Is that what it's saying?
Oh, well, a confidence interval, yeah, you totally can. Because the equation for the confidence interval is p hat plus or minus z z star. So it's like that.
Right.
You know.
I have it. I have the equation in front of me.
Yeah. Well, that's all you have to do. And
well, you don't have z though. That's the problem. I don't see z.
Oh.
You don't have z. And they don't tell you if they want 95% or 90 or 99%. So you don't even know, where to get it from the normal probability applet.
Oh, hold on.
And because I don't know Z, I'm totally cool. Like, you know, you can get Z without having to, you know, but you can only solve for Z if you at least know the upper or lower bound of the confidence interval, which we don't know.
Yeah, they need to give you the level of confidence or the level of significance to know.
That's what I was saying. So is that answer false then? Because like,
I
No.
submitted it. You.
how could it be true? You don't know the confidence interval. Like you don't know what they want, like 95%, 90 or 99, you know? That just makes no sense to me.
Oh, go back to the requirements for. Oh, because it might be talking about doing it in Excel. Oh no, I think you still need it.
Well, I'm looking. Yeah, you do. I'm looking in Excel. You need X, N, and
Maybe you just assume it's 95.
Yeah, you can plug in whatever confidence interval you want. You could plug in 99, 95, 90. It doesn't matter.
Doesn't that
Right?
fix the confidence interval though? If you plug in the confidence?
Yeah, it'll make it like closer.
yeah, it changes.
Yeah, so we can't do that.
I don't know. That's why I was
Yeah,
confused.
but it's
though. Like, that's a thing. Like because we didn't have Z, or what they want. Like, I don't know. It just seemed like you wouldn't be able to. I wouldn't be able to construct a confidence interval from that. At least not one. You know, I could take a crack at it and guess 95%. But if they wanted 90% or 99, I'd be screwed. So, oh well.
Well, just to tell you, like on the test, it'll be more specific anyway.
I hope
It'll
so.
give
'cause-
you. It will be more specific. They always are. In the group meetings, they're a little more vague.
Yeah, it's
but
like
on the test, it always makes sense.
I hope so, because it's questions like that that throw me off, and like I feel like because I read over the reading today and I was looking for that. I'm like, no, I can't construct a confidence interval from that. But whatever. If they say they can.
I don't know. I think maybe it just wants you to assume that you know the level of confidence, even though it's not given to you. Maybe they just wanted to see.
Like, could you construct any like confidence interval from that? Like,
Yeah, maybe that's
could
what
you
it's saying.
construct
Yeah.
like, yeah, if you wanted to put in 95 or 90 or 80 or whatever, it doesn't matter.
Yeah, because like
68.
it's usually a given that the confidence, the level of confidence is just usually a given. So maybe they're just excluding that from the question because they want you to focus more on the new material, which is, you know, P and P hat.
You can see how that's confusing though when I'm sitting there like, yeah, but I don't know what Z is, so
Well, I'm not
Well,
the one who wrote
See
this.
how it's confusing, Scott?
yeah, it's just like what the heck, man.
Near
Yeah.
impossible is what it is.
All right. Well, whatever.
I don't know if
Let's just-
if that question was like on the test, you could totally argue it.
Oh, for sure I
like,
could. I know I could.
Technically, it's like unclear.
I would
Technically,
assume 95% confidence interval, but I just don't know. So whatever. It's fine.
Yeah.
Okay.
Just guess.
Well, whatever. So question 6, the study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 were found
Just
guilty.
skip question 5, Scott, or you got that one?
It's true. Right?
Okay, cool.
It's true.
Okay. All right. Okay. So find the point estimate or p hat of the portion of first degree murder defendants who are found guilty in the state. It's x divided by n. So 45 divided by 60
Mm-hmm.
is
75.
0.75.
0.75. Scott on his game.
Do you know what's
Okay.
really confusing to me is like why they take something so simple as saying find the percentage of people that were found guilty
Yeah, seriously. Yeah, that's a good
and then
point.
give it tricky stats names. Find the
Very
point
gimmicky.
estimate.
Well, if people kept it that simple, you know, then statisticians probably would be out of a job. So, no, I'm just kidding. There's a lot more
Keep it
complicated.
confidential.
All right,
Very
let's see. I'm just kidding. You'll have a job, of course. Okay. Create a 95% confidence interval for the true proportion of first-degree murder trials in this state. The verdict is guilty. Input your answers for the margin of error, lower bound, and upper bound. Okay. Cool.
What you got there, Darren? Green apple? Looks nice. You want to share some?
Yeah, sure. Take a bite.
You're a champ, buddy.
This 9-6. Darn it.
Scott's the trooper in this group. You know what I mean?
I just want to make
Darren,
sure I understand everything, you know?
This is now the dynamic of the group. Darren has always done it early because and Michaela's a statistician.
Yeah.
Just like dragged
Jeez,
his
guys.
feet, and then he got with someone, and now he's feeling great about himself. And Scott's just like the one that's like, you know what, guys, I'm gonna show up. I'm gonna do the work. I'm gonna share my screen. I'm gonna be a team player.
I just want to make sure I get this stuff right, man.
That's why you're doing better on the test than I am. You know?
Well, I hate knowing that I'm behind. Okay. So I
You're not
have the
behind.
lower bound, and that's it so far. For the lower
Just
bound,
add
The lower bound.
I have 0.746325.
I got 0.64 in the lower bound.
0.64. Darn it. Let me recalculate that then. Because we just calculated p hat.
What's your margin of error?
0.11.
Hold on.
Oh,
a second.
sorry, Scott.
Wait. Wait, hold on a second. Did I think I
Yeah,
was calculating. I think I was
I
calculating the
spoiled
wrong
it.
thing. Sorry, give me
My
a second.
bad.
No, you're good. Oh, dude. I used 100 for N because I was still thinking of that stupid last question. Oh, man. That's the problem. I was like, what the heck did I do wrong this time?
Scott's
Okay.
rattled.
Man, I am. I'm like, this is ridiculous. I can't believe what's going on? Okay, all right, let me 0.75 times 0.25 divided by 60. And then get the square root of that.
Mm-hmm.
Multiplied by 1.96. So it's going to be 0.75 minus 0.109567, yada, yada. So it's 0.64. What I
Yes. Mm-hmm.
got. Okay. For the lower bound, right?
Correct.
Good. Thank goodness. Okay.
I'll give you a hint. You add 0.11.
Yeah.
to
Okay. 0.859, so 0.86. Wait.
Yep.
Round to 3 decimal places. Oh, whatever.
Guys, the Warriors took the finals. The Penguins took the cup. This is a crazy time we live in.
It's crazy times, man.
Yeah, what upsets?
All right, so now I have to get the margin of error, which is 1.96 times the square root of p, which I don't actually know what p is, to be honest with you. I know it's the true population proportion, so is that 0.75? Wait.
It's going to decrease the size of the width of the confidence interval. Because as your population increases,
Mm-hmm.
your like findings become more precise.
Yeah. I mean, like with it says like for the margin of error, so I have 1.96 times, and then obviously it's p multiplied by 1 minus p divided by n for the margin of error. So what is p? Because it's not p hat, it's just p.
The
What is
p-value?
Is it the p-value? I thought it was the true population proportion. Because there's p and then there's p hat and then there's p values, so there's like a crap ton of stuff.
How many p's? Honestly, I'm just going off of like just knowledge, just like if you increase the sample size, your confidence interval is going to become more precise.
What are you? Oh no, I'm not talking about. I'm on question 7. I already did 8 and 9. I'm talking about 7. I didn't do 7 yet.
Oh, sorry, I was
So
really.
am I just gonna add the 0.86 and 0.64 and divide by 2?
Yeah, you can do that.
Yeah, I might as well. I don't feel like doing their massive equation that they want me to do. So still just 0.75 is the margin of error.
No,
What?
it's the difference between the two divided by 2.
That's what
So
I
if you
did.
take upper bound minus lower bound divided by 2.
Yeah. You're right.
What is that?
Yeah.
To find the margin of error.
Which is 0.11, obviously.
Yeah.
Darn it. I know that. Hold on. Let me do an easier equation for margin of error. Upper bound minus lower bound.
Does your wife do weird things like cool her toast before she eats it?
Cool her toes?
Toast. Like British people, like they have like toaster stands, so they like toast bread, and then they'll like leave it out until it gets cold, and then they'll like put butter and like stuff on it. No, legit, I'm not joking. I'm not making this up.
I thought you said cool her toes, like toes.
Oh, like her feet?
Yeah, I was like, what is that? Let me shout, and well, actually, let me go after.
All right, so number 10 was decrease, obviously, right? The confidence interval.
Yeah.
Okay, number 11, to conduct a hypothesis test for one proportion, 2 requirements must be met. Suppose P is equal to 1/2. What is the smallest n can be and both requirements still be met? Is that 20?
Yeah.
20, yeah.
Sweet.
She says, no, that's disgusting, so it must be a Canadian thing.
What's disgusting?
Cooling your toast before eating it.
Ew.
My friend's parents do that, and they're from England.
That
And the
is
next-
so bizarre. Why? What is the point?
That is weird.
I
Question
don't
12
know.
is
They have like
100.
cooling racks specifically for cooling your toast.
That's weird.
Yeah, Scott, it is
Yeah.
100. You're right on track, buddy.
Sweet. Okay, good. I'm gaining some confidence back.
Oh.
They also eat like Marmite, which is disgusting.
Nasty.
Marmite?
That's a New Zealand thing.
It is foul.
Yeah, I think that's
No, it's
Australian and New Zealand.
No, Australian is
Isn't it
Vegemite.
Vegemite?
Australian is
Yeah, it's
Oh,
Vegemite.
Vegemite, yeah.
Yeah, Marmite.
Babe,
Mar-
Marmite?
It's from like.
Do you like it?
It's
My wife says
disgusting.
it's disgusting.
Nasty.
Oh, good. She's so Americanized. I love it.
Nasty.
So she says you either love it or hate it. It's like fry sauce.
Oh.
I don't like fry sauce.
I love
See?
it. What are you
Either love
talking
it or you
about?
hate it.
Good
Done.
stuff.
love
No, I
fry
don't. I really like ketchup.
That's good. What?
Scott, you got 13 is true.
Oh, wait. What? Hold on.
I don't even know who my wife is anymore.
13 is true.
Her name's Michaela.
What is Michaela? Is she even human?
How am I supposed to figure out if it's met? It looks like it's met just looking at it. Instinct tells me the conditions are met, so I'm just going to say true, I guess.
Okay, cool. I'd say
Okay.
that's a good thing.
Yeah, it's because they conducted a hypothesis for this. Yeah, they did.
Well, I see clearly there's a null hypothesis and, an alternative hypothesis, and they have some data that looks like it's sufficient to, so whatever. Okay. What is P hat? It's X over N. So 38 divided by 80 would be just under 0.5. Is 0.475.
Correct.
Yeah.
Find the test statistic. I'm gonna just plug this into the thing.
Cool.
Okay, 38, 80. Confidence interval is 0.95. Null hypothesis is 0.6. Test statistic is trying to figure out. I've never used this one before. I see p hat, standard deviation, p-value. I see the z-score, minus 2.282.
Yep.
That's it?
Yep.
Okay, thank goodness. All right, p-value is 0.989.
Wait,
Yes.
say that again?
The p-value is 0.989.
I got 0.011 for the p-value.
Darren, do you know what my favorite pie is?
Oh, shoot. I put greater
Cherry.
than instead of less than. You're right. I put greater than instead of less than. So
It's
yes.
banana. In case you're wondering.
Yeah.
I was wondering.
I love it.
So Scott, you did get the 0.011?
Yes, yeah, I did.
Okay.
I did p was greater than 0.6 and less than instead of less than.
Oh,
So
okay.
once I fixed it, it turned out fine. Okay. The decision is to 0.01, 0.5 is to reject the null, right?
Yep.
Because it's less than. Okay, awesome. Which of the following best summarizes the conclusion of the test? There is sufficient evidence to conclude that the water quality in the area has decreased.
Correct.
Yeah.
All right. Now
Is
to
it
submit.
weird that it says there's only 18 questions, but when you submit it, it says 19 out of 19?
Really?
Yeah. That is weird. Oh, it's because some are
Yeah.
worth 2 points and some are
Oh,
worth half
yeah.
points.
Yeah. There you go.
Oh, okay.
Got 100%.
Okay, cool.
Oh, man, that was one of the worst homeworks for some reason. I don't even know why. It's just frustrating.
Yeah.
I hope the rest
Really,
of the semester
really
is not like
was.
that. All right.
Hopefully not.
And the sad thing is, I actually read through all the reading this time, and I was just as confused as if I probably wouldn't have read through, Oh gosh. All right. Well, cool.
You're a champ.
Thanks, guys. Thanks for helping me out. Thanks for being patient.
No worries, man.
Thank you for being patient with us.
Oh, you're good. I'm just glad that you guys are good too.